Good afternoon friends, and welcome again to another session of Parijat sir classes. As you can see this, and today what we will be doing is we will be continuing the differential equations part 3. We have already uploaded part 1 and part 2. This is the differential equation part 3. So I would suggest you, please, first of all, you should go through the differential equations part 1 and part 2 before you proceed to the differential equations part 3, because part 1 and part 2 are the continuations of this, and so this will be only helpful if you are aware with part 1 and part 2. Okay, so this is my personal number. You can contact me or message me or WhatsApp me. Any problem you are facing for anything, you can just contact through me. So this is Parijat sir classes. So please like, share and subscribe the channel so that you can be updated with all the videos which I am uploading, which is very helpful for your board examination purposes, both maths and physics. So please subscribe the channel so that you can get all the updations of any new videos which are coming. So let's get started with the differential equations part 3, and let's see what is it inside that. Now in the part 3, in the part 1 and 2, I already showed you that you have to separate the x and y variables, and then only you can integrate both the parts. But there are certain equations where you cannot separate x and y. So this is the part 3, how we will be doing those sums where you cannot separate x and y. So first of all, see, the sum shows it is sine inverse. The sum is showing this is sine inverse x plus y. Sine inverse dy by dx is x plus y. So see, how do we do that? Dy by dx equal to sine x plus y. Now we cannot separate x and y from here. So what we have to do, please remember this step. When you cannot separate, then you have to take x plus y as v and then differentiate. So x is 1, y is dy by dx, and v is dv by dx. Now in place of dy by dx, you have to put this. So here is your dy by dx. So in place of this, we will put this dy by, this is the dy by dx part, and in place of x plus y, we have taken v. So now it becomes very easy for us to separate the v and the dx. The v part and the x part, it is very easy for us to separate it. And now after separating, please put the integration sign. First of all, you will separate the v parts and the x part. Here there are two variables, that is the v and the x. That means you should have dv part on one side and dx part on the other side. Okay, so please remember, dv should always be in the numerator, dx should always be in the numerator. Okay, so now, so this is how we separate the dv and the dx and give the integration sign. So integration of 1 plus sine v, how to do that? Multiply by 1 minus sine v up and down. So this becomes 1 minus sine v by cos square v. Now separate the variables, separate the terms like this. So 1 by cos square v, and sine v by cos square v is what? Tan v sec v. Tan v and sec v, and this is dx. This is sec square. This is tan v sec v. Integration of sec square is tan v. Integration of tan v sec v is sec v. Integration of dx is x plus c. Now in place of v, replace x plus y, and that is your differential equation. This becomes your differential equation. Okay, so your main part will be to how to separate the two variables x and y. If you cannot, then please put x plus y equal to v. So the second sum shows, this is the second sum. Here also it is very difficult for us to separate the x and y. It's very difficult to separate x and y. So what we do is that we put this as v and now differentiate. So 4x differentiation is 4, y is dy by dx, 1 is 0, and v is dv by dx. That means in place of dy by dx put dv by dx minus 4. So here we have replaced it. Dy by dx is dv by dx minus 4 and this is v square. Now it becomes easy for us to separate the dv part and the dx part and put the integration signs. Now integration of this left side, the integration of the left side, as you are all aware that dx by x square plus a square is 1 by a tan inverse x by a. So that only we have given. So 1 by our a is 2, our a is 2, so 1 by 2 tan inverse x by a, so v by 2 x plus c, and now in place of v we put the 4x plus y plus 1, and that is the differential equations. So this is the differential equation of this. Similarly, if this is the sum, we cannot separate x and y from here. So again let us put x plus y equal to v, differentiate on both sides with respect to x, replace dy by dx with this. So here we have replaced, this becomes v square, dy by dx is this equal to a square. And now our target will be to separate the dv and the dx. So see how we are separating, minus 1 goes on this side, it becomes this, and now it becomes easy for us to separate all the v with dv on one side and x with dx on the other side. And now integrate, give the integration sign. So how to integrate the left hand side? So we have taken a plus a square and a minus a square, plus a square and a minus a square, and we have arranged it like this. So the first one becomes integration of dv, second one, it is a square is outside, and this is the formula of integration of 1 by integration of dx by x square plus a square type is 1 by a tan inverse x by a. This formula is applied here, 1 by a tan inverse v by a. Okay, so this becomes a, and integration of dx is x, and now in place of v replace with x plus y, and that is your differential equation. That is your differential equation. So let us now see the next sum. Let's see the next sum. So next sum says cos x plus y dy is equal to dx. So again see, we are not able to separate the x and y. So let's take x plus y equal to v. Same way, differentiation of x is 1, y is dy by dx, v is dv by dx. Separate the dy by dx and replace it. So this is dy by dx. Okay, dy by dx is this. So from here what do we get? It will become cos v. So dy by dx will be 1 by cos v. Please see here, dy by dx is actually 1 by cos x plus y. So dy by dx is this. This is the dy by dx. 1 by cos v, v is x plus y. So it plus 1 minus 1 comes on this side. So sec v plus 1. And now we separate the dv and the dx and give integration sign. So 1 by sec v is 1 by cos v, it becomes this. So we are adjusting with plus 1 and minus 1 here. We added plus 1 and minus 1. So it becomes this. So this cuts and becomes only dv. And this is 1 plus cos v is 2 cos square v by 2. 1 plus cos v is 2 cos square v by 2. So half comes out, sec square v by 2. Sec square is tan, and v by 2 means by half. By half. Okay. So sec square v by 2 will be tan v by 2 by half. By half, because here the value with x is, with v is half. So by half. So this cuts, this is tan v by 2, and now replace the value of v. Now replace the value of v and we get, this is the differential equation. Now see, there is one more thing. They are telling y0 equal to 0. It means when x is 0, the value of y will be 0. When x is 0, value of y will be 0. So if x is 0, y is 0. That means in this equation, in place of x put 0, in place of y put 0. So you are getting c equal to tan 0, though, so c should be 0. That means now replace the value of c. This value of c is actually 0. So actual equation becomes this. That means this is the, from here x and x cuts. So y equal to tan x plus y by 2. This is the solution of the differential equation. Next, solve dy by dx equal to this. So again, see, we cannot separate x and y. So let's x plus y equal to v, same way, and do differentiation. X is 1, y is dy by dx, v is dv by dx. Separate dy by dx from here, which is this, and now replace it. So in place of dy, in place of this dy by dx, we'll put dv by dx minus 1, and in place of this x plus y and this x plus y, we will put v and v. Now take the one on this side. So now separate dv and dx and put integration. So we have to solve this. So what we are doing is, please watch here, we know cos 2x is 1 minus tan square x by 1 plus tan square x, and sin 2x two tan x by 1 plus tan square x. So we will now put it here. So cos v, please look here, cos v, that means here 2x is acting as v, 2x is acting as v. So this x will act as v by 2, this x will act as v by 2. Similarly, 2x is acting as v, so this x will act as v by 2. So putting it here, and now taking the LCM, 1 plus tan square v by 2, which goes up. Solving this, we get this. So 1 plus tan square theta is sec square this. Okay, and now let us take tan v by 1 plus tan v by 2 as t. So differentiated, 1 is 0, tan is sec square, tan v by 2 will be sec square v by 2, and v by 2 will be half, into dv will be dt. We are differentiating this. So now that means, you see, half sec square v by 2 dv is actually dt. So this is the half sec square v by 2 dv, which is actually dt. So this becomes dt, and down that we have taken as t. So it is, right side is this. So this is log t. This is x plus c. Now replace t. T is actually 1 plus tan v by 2. Now in place of v, you replace x plus y. Okay. So this is the solution of the equation. This becomes the solution of this equation. Next, solve x plus y plus 1 whole square dy equal to dx of this. Okay, this is used to find the value of c. So we will do it last. So we cannot separate x and y, so we will take this whole thing as v. So now differentiate 1 plus dy by dx plus this is 0 equal to dv by dx. So dy by dx is separated. That means in place of dy by dx, you will put this. So this was the sum. So dy by dx is actually this, and this is actually v. So v square plus 1 comes on this side, it becomes this. Now separate the v, all the v variables here and all the x variables here, and give integration sign. So now add plus 1 and minus 1. See, we added plus 1 and we added minus 1 here. Okay, so this cuts, so it is actually dv, and this is tan inverse v integration. So integration of dv is v, tan inverse v, and integration of dx is x plus c. So now replace the value of v. Now this shows that if x is 1, if x is minus 1, this shows that if x is minus 1, y is 0. So we will put these values in this equation. So if x is minus 1, y is 0, x is minus 1, y is 0, x is minus 1. So we are getting this as 0. Tan inverse 0 is 0, and this is minus 1 plus c. So c is equal to 1. Now this value of c will be replaced here. Okay, so that will give me the ultimate solution of the equation. This is the value of c. Clear? So from here 1x and 1x cuts. So this is the answer of the solution. This is the solution. Next, the sum shows this x minus y dx plus dy dx minus dy. This we will use to solve the value of the c. So we can see here that we can, if I open the bracket, this dx and dx, this dx will come on this side as minus dx, and with the, and all the dy is on one side. Now take dx common and dy common, and write dy by dx equal to this. So from here we see that we cannot separate x and y. We cannot separate all the y together and all the x together. So that is why we have to put x minus y equal to v, and then differentiate this. So replacing the value of dy by dx by this in this equation. We will replace this dy by dx in this equation. Okay, so it becomes this, dy by dx is this, and it is a minus, this was this x minus y is v, v minus 1, and this x minus y is v, so v plus 1. So this is actually 1 minus v by 1 plus v. Take minus on this side, so this becomes this. Solving it, we get minus 1 and minus 1 cuts, so it is 2v by this. So now separating all the v's together and all the x together and putting integration signs, putting the integration signs. So we will solve this now. Okay, so how to solve it? Let us separate it. Becomes this. So this is log v, half log v, this is half v, this is x plus c. Now in this equation, see what to do. If I take half as LCM, 2 as LCM, it becomes this. Okay, so please watch one thing. If I take 2 as LCM, this should become 2c, this should become 2c, but again that c is a constant, so we will keep on writing that as a constant only. So don't write 2c, because 2c, c is a constant, 2c is a constant, 100c is also a constant, c by 100 is also a constant, minus c by 2, this is all constant. So whenever you see that you are getting a constant, you can write c. And now replace the value of v wherever it is. Okay, so 1x from here and x from here will cut, so it will be minus of x plus y equal to c. And now replace the value of x. So watch here, this means x is 0, y is minus 1. It means that. So replace x with 0 and y with minus 1, and you will get the values of the c. C will come 1. That means put this value here. So the equation becomes this. This is the final solution of the differential equation. Next, the next term, what we will do is a homogeneous equation. Homogeneous. When differential equations are homogeneous, this is another type. Homogeneous equations. Okay. So what is a homogeneous equation? What is a homogeneous equation? When the power of the denominator and the numerator will be same, or the degree of the numerator, degree of the polynomial function in the numerator and degree of the denominator will be same, will be equal, then we call it a homogeneous equation. And if it is a homogeneous, then we will put y equal to vx. Please note that. If it is a homogeneous equation, we will put y equal to vx. So let's see the first homogeneous equation. This is the sum given to us. Okay. So first of all, separate the dy by dx, and now this, in this equation, please watch what is the, this is the equation. Please watch what is the degree here. If you multiply xy, this is the numerator minus y2 by x2. See, the power is 1 plus 1, which is 2. The power is 2. The power is 2. That means the power at the numerator and the denominator, or the degree at the numerator and the denominator, are same. So both are having the same degree in the numerator and denominator. So we will call it as a homogeneous. And if it is a homogeneous, we will put y equal to vx. Now differentiate. Y is dy by dx, and vx is used as a product rule. So first we keep v and do x. X is 1. And now we keep x, we will do v. V is dv by dx. So in place of dy by dx, I will replace this value. So this is the dy by dx, equal to, in place of y, we will put vx and vx. So it becomes this. So x square gets cut. X square gets cut. So it becomes this. And now open this bracket and we will bring this v on this side. It becomes minus 2v minus v square. Now we will separate all the v and we will separate all the x together, keeping dv at the top and dx at the top, because dv and dx cannot be in the denominator. And now we will put the integration sign after separating the variables. We will put the integration signs and differentiate and integrate it. Okay. So in this case, see, this is the formula of dx by x square minus a square, and the formula is what? Half log mod of x minus a by x plus a. So this is the x minus a by x plus a. Clear? And this is log x. So this becomes v by v plus 2 minus log x plus c. And how to solve this? So watch here. After this, so here it comes. Now in place of v, we will put y by x. So this is log c. Now if c is a constant, I can also think that log c will also be a constant. Okay, so instead of c we will write log c. Why? Because the other two terms are coming in log. That is why instead of c I will write log c, because the other two terms are also coming in a log. So this minus log x come on this side, and half goes as a power, so it becomes root over this. So log a plus log b is actually log a into b. Log a into b equal to log c. Log cuts. So this, now in this equation we have to find the value of c. So already they told that in this part, if x is 1, y is 1. So using this, so we are putting the x and y as 1. We calculate this. C is coming root 1 by root 3. So now replace 1 by root 3 here in this equation, and we get this. And removing the root, squaring both sides, this is the solution of the equation. This is the solution of this equation. Okay. So friends, let's see the next sum. Let's go to the next sum and see what is the sum. Okay. So here, this is the equation given to us, and this part is used to find the value of c. So from here we can see that if I separate dy by dx, I am getting this term. And now this is a homogeneous equation, because numerator degree is 1, denominator degree is 1. Okay. So degree means the power. Here the power is 1, here the power is 1. So numerator power is 1, degrees power is 1, and here is 1, and here is 1. So denominator and numerator, both degrees are same. That means it is a homogeneous equation. So if it's a homogeneous, then y is equal to vx. We have to put that and differentiate it. So y becomes dy by dx, and v into x is the product rule. We use the product rule here. And now in place of dy by dx, I will replace in this equation, and we get this. This is y equal to vx and vx. Taking x common, we get this. Okay. So now we reach till here, and now this v will come on this side as minus v. So this and this cuts. So it comes out to be this. And now we can separate all the v's together and all the x's together and give an integration sign. Okay. So how to do this? Separate it. We'll get the formula. So this is tan inverse v. This is tan inverse v. And this is, if I take 1 plus v square as z. If I take 1 plus v square as z, so what will happen? 1 plus v square, if I take as suppose t, so differentiated, this will come 2v dt equal 2v dv equal to dt. Okay. So 2v dv means dt. So here we have adjusted half and 2. This part we are separating, this part. So we are adjusting with half, and now 2v dv is equal to dt. So instead of this I write dt, and 1 plus v square I have taken as t. So this integration of dt by t becomes log t, and this is log x plus c. Now replace the value of t. What was t? T was 1 plus v square, and this v was y by x, because y equal to vx. Y was equal to vx, so v will be y by x. And t, what is t? t will be 1 plus v square and v will be y by x. So I can write t is equal to 1 plus y square by x square. Here we are writing it, okay, minus log c plus c. And now we have to find the value of c. So if x is 1, y is 1, that means keep putting x as 1 and y as 1. So this becomes tan inverse 1. This becomes half log 1 plus 1. This is tan minus log 1. Log 1 is 0, so this becomes 0. This is half log 2 and tan inverse 1 is pi by 4. Tan inverse 1 is actually pi by 4. So this is that pi by 4 plus half log 2 plus c. So from there we find out the value of c. This is the value of c. And now replace the value of c here in this equation. In this equation we will replace the value of c. So it comes out to be this equation. This is the c. This is our c. This is how we solve the differential equations of a homogeneous equation. Differential solutions of a homogeneous equation. Let us now see the next sum. The next sum says this. So first of all, let us separate the dy by dx. And this numerator says the degree is 2 and down degree is also 2 because 1 plus 1 degree is 2. So it's a homogeneous, and when it is a homogeneous you have to take y equal to vx and differentiate it on both sides. And then replace dy by dx as this much. So here we have replaced it. This is the dy by dx. And in place of, see, we have taken y equal to vx. So this becomes y square, x square minus y square becomes v square x square. It was 2xy. So this is the y. So it takes x square is common. It cuts. It remains this, plus v goes on this side minus v. It becomes this, and now we are separating all the v parts with the x parts and giving integration sign. Giving the integration sign. Now let us take 1 plus v square as t. So 2v dt will become dt. So this is our 2v dv. 2v dv becomes dt. And the bottom part we have taken as t. So this is the t, and here is dx by x integration. So this is minus log t. This is log x. So we will take the constant as log c. Because two other numbers are coming in log, so the constant will be written in log c. That means this log x goes on this side. So taking minus common, log t plus log x. Take minus common, log t plus log x. So this is actually log a plus log b. Log a plus log b is log a into b. Log a into b. So here we got, and now replacing the value of t. Log cuts. This is minus. There was a minus here. Please remember here. Minus log x is actually log x to the power minus 1, which is log 1 by x. So here only we have given. This minus will go at the top of this. So it is minus 1. That is why it becomes 1 by xt. So log cuts, and in place of t I will put 1 plus v square, and then again in place of v I will put y by x. Now what we are doing, we are calculating the value of c. If x is 1, y is 1, so keep putting the value of x1 and y1. x1 and y1 gives you the value of c as half. Now replace the value of c in this equation here. Replace the value of c in this equation. Okay, so what do we get? C is half. That means x square plus y square equal to 2x. This is the solution of this equation. Okay friends, let's see the next sum. So we are seeing this sum. That means solve x square y dx minus x cube y cube dy equal to 0. First separate dy by dx and check for the homogeneity. Yes, power is 1, so that at the top degree is 3, at the denominator degree is 3, so it is a homogeneous equation. So take y equal to vx and differentiate it. Dy by dx equal to v x plus dv by dx. So in place of dy by dx, put this value here, and in place of y, put the value as vx. So it becomes this. So now taking x cube common, so they cut and take the plus v on this side, do LCM, it comes this. So now it is easy for us to separate the v parts. It is easy for us to separate the v parts. So this v actually gets cut, plus v and minus v. So it comes to be this, and now it becomes easy for us to separate the v parts together, x parts together. Please remember, dv, dx, dy, dt, they cannot be at the denominator. So from here, what can we see? We are separating. First 1 by v to the power 4, which is actually v to the power minus 4 dv. Then v cube by v4 is actually 1 by v. So this is v to the power minus 3 by minus 3. This is log v. This is minus log x plus c. Now it is v to the power minus 3 becomes 1 by v to the power 3. Now we will replace the value of v, because y is equal to vx. So x will be equal to y by x will be equal in place of y we will put vx. That's it. So in place of v, it should be y by x. So here we are replacing the value of v, y cube by x cube, y by x, and now we are supposed to find the value of c. So this is log a plus log b. Log a plus log b is log a into b. It comes out this, and now okay, you don't have to find the value of b here, just we have to leave it like this. This is the answer of the solution equation. This is the answer of the solution equation. Next, solve this equal to this. So we are separating the x and y component, we are getting this, and we see that the degree at the top is actually 2, 2, 2 and 1 plus 1, which is 2. So the degree is, it is a homogeneous equation with degree 2. So we have to take y is equal to vx. We have to take y is equal to vx, and now differentiate on both sides with respect to x. So dy by dx will be v, and this is the product rule we will apply, and we will get this. So now in place of dy by dx, replace by this, and in place of y, every y, keep putting your v square by keep putting your vx. So this becomes v square x square, this becomes x square v. Take x square common, it cuts this. Take the v on this side as minus v. Solving it, we get this is the solution. Now we can easily separate the dv part with all the v and the x part. So now how to do this? Please watch one thing. If I take minus 1, it is actually 1 minus v. So can I write the numerator like this? Yes, we can write it like this. Now separately writing it, and this, so they will cut out. When you separate it, 2 by 1 by v will be left, and minus 1 minus v by 1 minus v will cut off, and we will add only dv and dx. So now this is 2 log minus log 1 minus v, and this is minus v, this is log x, this is log c. So then we have to now just replace it. So all things on one side. So this power before the log will go here. It will be 1 minus v whole square. So log a plus log b plus log c is log a into b into c. Please watch here. Log a plus log b plus log c. There is a formula, log a plus log b, and this power 2 will go up first of all. This power 2 will go up here like this. So log a plus log b plus log c is log a into b into c. So here we have done till here, and now we have to replace the value of v, which is y by x. So inside the bracket it becomes this. Just simplify and cutting 1 x, it becomes this. Now how to remove? Please note one thing, log EA equal to B, we can write e to the power B is equal to A. So here is the E, remember. So e to the power of this will become this whole thing. So this is the ultimate solution of the equation of this type of homogeneous equation. Solution is this. Let's see the next sum, friends. So this is the next sum, and let us now solve this sum. Solve this and this. So first of all separate it. So see, here power is 1 1, which is 2, and 2, and 1 plus 1 is 2, and 2. That means degree at the top, at the numerator and denominator is 2, which is a homogeneous equation. So we will take y is equal to vx. We will take y is equal to vx, and now differentiate on both sides, and then replace the value of dy by dx with this. This is the dy by dx. Okay, and so from here we will now, in this y, we will put v by x Vx, this will become v square x square, and this will become Vx. So here we put, so x square is common, they cut off, and now this V which was here comes to this side as minus V. Solve it, we can get this, and now we have to separate all the dv and the dx parts. So here we have separated it, all the dv parts together, all the dx parts together. So how to solve this part first of all? So what we will do is that we will take here a 1 by 4. We will take here a 1 by 4. Okay, first of all from here we will take a 2. So already 2 will come out, and then we will write 1 by 4 to adjust this 2. This 2. First of all a 2 comes from the denominator, and then so it becomes half, and then we will take another half which becomes 1 by 4, and that 2 is adjusted at the numerator. And now we will take it, this lower part, as t, differentiate it, 2v becomes 2, dv equal to dt. So see, the upper part is becoming dt and the lower part is becoming t. So this is 1 by 4 log t, minus becomes plus log x, equal to the constant can be written as log c, log c. So that still is a constant. Now the power 1 by 4 will go at the top of t. Okay, so it becomes, or we are taking a LCM here as 4, so 4 log x equal to 4 log c. Now instead of the t, this t we will replace with v square plus 2v, because we have taken v square plus 2v as t, so we are replacing it, and this 4 goes as a power. So now in place of v, replace, so this is log a plus log b. This is acting as a log a plus log b. So let's see. Log a plus log b is log a into b. So here we have applied log a into v. A into v is log c. Log cuts, it becomes this. Now in place of v, we will replace y by x and solve it, and we get the differential equation. This is how we get the differential equation. Let's see the next thing. So the next sum shows, okay friends, so the next sum, see, solve this is equal to this. First of all, separate the dy by dx. So see, the degree is 3, 1 plus 2 is 3, 3, 2 plus 1 is 3. So the degree is 3. It is a homogeneous. So take y equal to vx. Same way, differentiate. So dy by dx equal to v plus x dv by dx. Now in place of dv by dx, here is the dv by dx. So replace this with this. And in place of every y, put v by x, v into x. So we get this. Take common, it comes out. Now plus v goes on this side, you solve it and you get this part, this part. Now separate the dv and the dx and give integration sign. Separate the dv and dx and get integration sign. So now separately writing it. So we are adjusting by 2 and into 2. Okay, and this is log x plus c. So now we'll take v to the power 4 as t square. So it becomes 2v cube, 4v cube dv. So see, v cube dv is actually 2 by 4, which is t by 2 dt. Okay, so this becomes 1 by 2 dt, 1 by 2 t dt, and this I have taken as t square, which is this. So t4 will, v4 will be t square, and in this sum I have taken v square equal to z. So 2v dv equal to dz. So dv dv equal to dz by 2. So this is that dz by 2, and v4 means z4, z square, because we have taken z v square as z. So now we will again take here 1 minus t square as k. So differentiating it, minus 2t dt equal to dk. Okay, so t dt will be equal to minus dk by 2. So this is the minus dk by 2. Already half was there. It becomes 1 by 4. And the bottom becomes k. Now this formula is integration of one minute. This formula is the integration of a square minus x square, which is 1 by 2 log x minus x plus a by x minus a plus x by a minus x is the formula. And in place of z, we will replace it by v square. Okay, this is log k, and k is replaced by 1 minus t square. So again we have to replace t. What is t square? T square is v4. T square is v4. So let's see. So here we are separating t square, and v is actually y by x, y by x. So now writing it like this, log x plus c. So let us make this as log c and take an LCM of 4. So this becomes 4 log c. Okay, so this power of 3 goes up. So now it becomes minus common, it becomes log a plus log b, which is log a into b, equal to, again this 4 will go up as a power. So log x to the power 4 plus log c to the power 4. So it becomes this, log cuts on both sides. So log will cut on both sides, and it becomes this, log will cut on both sides, and it becomes this. Now writing it in a proper way, this is the solution of this equation. This is the solution of this equation. So friends, next let us see the next sum. So this is the next sum, as you can see here. Y this is the next sum. It's a big sum. So first our target will be to separate the dy by dx from everybody. So this is that separation, and we see the degree at the up is 1 1 1 1 1 1 1 1 1 1 1 1 1 1. That means degree at the top is 1. Numerator and denominator, it's a homogeneous equation, so we will take y equal to vx, differentiate it. Now in place of dy by dx replace it, and in place of y keep putting the vx. So if you put vx here, it will become v. If you put vx here, it will become v. If you put vx here, it will become v. Okay, so the everywhere if you put vx here, it will become v. So ultimately it comes out to be like this, and taking x common, it gets cut. So this is the sum, and now take this plus v on this side as minus v. Take the plus v on this side as minus v. Taking the LCM, these things cut out, and ultimately one x also cuts out. So ultimately it comes out to be this. Now separate all the v dv with the dx and x and put an integration sign. Now separately write it. Here v and v will cut, it becomes half tan v dv, and here it will become 1 by v. Here cos v will cut. Now this is tan v is log sec v, and minus half log v log x plus log c. Okay, so take half common from these two, take half common. So log a minus log b is log a by b, and it becomes, this LCM will be 2. It gets multiplied on this side, that means 2 will go up as x square, and this LCM will be taken as 2. That 2 gets multiplied here. That 2 will, if I take LCM, that 2 will get multiplied here, and this will then go as a power here, and it will become x square. So log a plus log b is log a into b, cutting log on both sides. And now in place of v, I will put y by x. So y by x, and one x cuts, it comes out to be this. So this is the solution of this equation. Next, let's see another sum, friends. Solve this equation. So separate the dy by dx. First of all, separating dy by dx, we will see that it's a degree of 1 1 1 1 1 1 1 1. So it's a homogeneous degree of homogeneous degree is 1. So in place of, now please watch one thing here. In this we cannot make dy by dx, we cannot make it dy by dx, we cannot separate dy by dx. So that is why we have to try for dx by dy. We have to try for dx by dy. That is why you will take it as x equal to vy. Now we will take x equal to vy because we cannot frame dy by dx. We cannot frame dy by dx. So we have to put x equal to vy and separate the dx by dy now. Okay, so now let us do the differentiation of this. It becomes this. So this sum, if I separate dx by dy, it will look like this. So in place of x, put vy, vy and vy, and we get this. And this is the value of dy by dx. So now taking y common, it cuts, and now plus v goes on this side as minus v. Taking LCM, solving it, we get this. Now we can separate all the dv and the dy together and put integration sign. So this is actually 2 e to the power v only, and this is minus log y plus c, and in place of v we'll put x by y, and that is the solution of this equation. Next, let's see friends, next another sum. So this sum says it's again a homogeneous equation, but we can't separate dy by dx. We cannot separate this. So we have to go for dx by dy, and for that we have to take x equal to vy. Let x equal to vy. So see, this is the homogeneous equation. Power 1, degree 1, 1, 1, 1, 1, 1, 1, 1. So degree at the numerator and denominator is 1. So it is a homogeneous equation, but we cannot separate. It is not possible for us to separate the dy by dx. That is why we are going for dx by dy. And when we do that, we have to take x equal to vy. Now separate, differentiated dx by dy, v, it will be y dv by dy. So in place of dx by dy, in place of this I will put this. So here we have put, and in place of x we will put vy. So this is the vy, this is the vy. Okay. So now we'll take y common from the denominator, and y will cut out from the numerator and the denominator. Actually y will cut out, and this part, on taking LCM, we cut out this, so it remains this. So now we cut out that y which is common, and now we can separate the dv with all the v's and the dy with the y, and put integration sign. So now separately writing it, it becomes 1 by v dv, and this by this, it becomes 1 by v square e to the power 1 by v, this. Now this is log v, and for this let us take 1 by v as, let us take 1 by v as y, as t. So minus 1 by v square dv equal to dt. So here it is minus 1 by v square dv. This is dv, and 1 by v square minus. So it becomes dt. Okay. This is log y, minus log y comes on this side as plus log y, and this goes on this side. So it becomes this. So 1 by v I have taken as t, and minus 1 by v square dv equal to, so dt, and e to the power t. So now let's see how to solve it. So this is the thing. Please watch here. It was log v into y, and this. So now integration of this. Now please watch one thing. We have to integrate it, but this is a product form. This is the product form of the integration. So let us name this integration as I. So here is what we are doing, solving the I. So please watch here. For the product form, we have got the formula I late, I for inverse, L for log, A for algebras, T for trigonometry, E for exponential. So out of this there is a trigonometry and there is an exponential. So which one shall I take U? So trigonometry comes first. That means sin t will be taken as U. Okay. And what is the product rules formula? If it is U into V dx, so what we will do? U V dx minus integration of differentiation of U integration of V dx into dx. So remember, this is the formula for the product rule. This is the formula for the product rule which we have to follow. So product rule for this is the product rule for the integration. Okay, and this is a rule you have to follow. Which one to take U? Whichever serially comes first, that will be taken as U. So in this sum, the sin t will be taken as U and e to the power minus t will be taken as V. So U, this is dV by, this is V dt, and differentiation of U into integration of e to the power minus t will be e to the power minus t dt. This is e to the power minus t only. Now this again we will take as separate integration, where cos t will be taken as U and this will be taken as V. So here U integration of V dt minus differentiation of U into integration of V dt, again integration. So full integration of this. So it gives you this. Now this is actually I. This is actually I. So minus I goes on this side, becomes twice I. So twice I is equal to this, so I will be equal to this. So this is the solution of that I. And now we will put it here. So here we have put the solution. There is a minus, it becomes plus C. Now in place of V, I will put x by y. Okay, so that is the solution of this equation. Clear? So you have to know the product rule of the integration before doing this. Let's see the next sum. The next sum is here. 2xy plus y square equal minus this equal to 0. This is our equation which we have to solve. Okay, and this is for finding the value of the c. So first of all, we cannot separate dy by dx, so we have to separate dx by dy, and this is a homogeneous equation. We can see that the degree is 2, 1 plus 1 is 2 and 2. So we have to take x equal to vy. So differentiating this, dx by dy is actually this. So now we will put it here. This was the dx by dy. and in place of x I will put vy. In place of x I will put vy. Taking y square common, they will cut out, it remains this. Taking the v on this side, it comes this. Solving it, we get this. Now separate all the dy and dv. It comes this. So now this can be separately written 2 v by v is 1 and it is 1 by v, this. So it is 2v log v minus log y plus c. In place of v I will put the value of x by y. Now we have to find the value of c, because they have given this condition. They have given this, if x is 1, y is 2. Okay, if x is 1, y is 2. So in place of x we will put 1 and y we will put as 2. So here we are putting x as 1, y is 2, x as 1, y is 2, y is 2. Okay, so this 2 cuts, it becomes 1. This is log 1 minus log 2. Please note that log a by b is log a minus log b. So log 1 minus log 2. Log 1 is 0 and log 2 from here cut, so c becomes 1. That means replace the value of c in this equation and the solution becomes this. This is your solution. Next, this is the sum given. So again we cannot separate dy by dx, so we have to go for dx by dy. And see, the degree up is 1 plus 1, 2, and here is 2 and 2. So the degree is 2, so it's a homogeneous. So put x equal to vy, differentiate it. So this is the value of dx by dy. So replace dx by dy by this. Replace the dx by dy by this, and in place of x put y, v into y. Take y square common up and down, cuts. Take the minus v on this side, solve it, and now it comes this. And now we can separate the dv and the dy and integrate it. So separately writing it, it becomes this 2 by v cube is v to the power minus 3. So log v, and it becomes plus 1 by v square. This is log y plus c. In place of v put x by y. In place of v square, this. Now we have to calculate the value of the c. So here they are telling if x is 1, y is 1. So here x is 1, y is 1, which means log 1, which is 0. X is 1, y is 1, it gives you 1. Log 1 is 0 again. So c comes out to be 1. That means we will replace the value of c as 1. So what we have done here is we have taken an LCM of x square. So this multiplied x square, this multiplied with x square, 1 multiplied with x square, and log x by y, log x by y is log x minus log y. So multiplying this, opening this, so it becomes 2x square log y. So this is the last solution of this particular sum, and with this we finish the differential equation part 3, where we have studied the homogeneous sums of the differential equation. We have studied the homogeneous sums of the differential equation. Okay, so friends, my suggestion again is that please go through the differential equation part 1 and part 2. Part 1 and 2. Then only you will be able to understand this. And we have studied today homogeneous equation. We have studied today differential equations which are homogeneous type. That differential equation we have studied today. So hope you have understood, and please continue watching the channel so that you are updated with all the videos which are being uploaded for the physics and the mathematics part. So I would request you, please go through the channel and like, share and subscribe. Definitely do that. Okay, so thank you very much till then for watching Parijat sir classes, and get updated with the new videos with physics and mathematics.